Hello to all of you. This is Dr. Dhaval Mehta, and today we are going to discuss machine learning workflows with pipeline. Whenever we collect the data, a very common problem exists is the data leakage. So before running any machine learning algorithm, we have to do a lot of pre-processing. Now this pre-processing causes the data leakages. In general, the data normalization is done by dividing the data. So normalization is a pre-process which we do. How we do it? It is done by dividing the data by its mean value. Then it is applied to entire data sets. This results in the overlapping of training data sets with the test data sets, which causes the data leakage problems in the model. Now, how to overcome it? The remedy is automated pipelines. Pipelines have been growing in popularity and now they are everywhere in data science, ranging from simple data pipelines to the complex machine learning pipelines. Python scikit-learn provides a pipeline utility to help automate machine learning workflows. Pipelines work by allowing for a linear sequence of data transforms to be chained together, culminating in a modeling process that can be evaluated. I will explain this in a very simple way. If we are done running the machine learning algorithm manually, we collect the data, then the data extraction and analysis is being carried out, then the data is prepared, model training, model evaluation and validation, then the trained model, the model is being trained, then we go for model registry and model survey. Basically, till here it's machine learning and here the operations are there. This is done manually. Now, if there are data leakages problem, we'll have to update the algorithm every time. So instead of doing this manually, if we carry out the entire process with the help of pipelines, you can see that the entire thing is now in the automated pipeline where data extraction, data validation, data preparation, model training, model evaluation, model validation. So the data leakage which can happen at each and every stage can be restricted. Moreover, after the trained model is there, then the model serving, model monitoring, the feedback mechanism is being created so that we can create better and better models. Moreover, every time new code is being generated to avoid the data leakage problems. Now, how we can carry out this automated pipelines? Let's see in Jupyter Notebook. From pandas import read underscore CSV. From sklearn.model underscore selection import kfold. From sklearn.model underscore selection import cross validation scores. From sklearn pre-processing import standard scalars. This is basically pre-processing. From sklearn.pipeline import the pipeline. From sklearn.discriminant underscore analysis import linear discriminant analysis. Now, this is the data set on which we want to carry out the automated pipelines. So, we are specifying the file name. There's a Pima Indian Diabetes. This data set is very easily available on the Kaggle website. So, I've specified the path where my data is located. Now, well, I'll specify the names of the variable. Data frame is equal to read underscore CSV. This is a file name. Basically, by specifying here, I'm trying to fetch the data from here. File name, names is equal to names. So this is the names of the variable. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series. Data frame is equal to read underscore CSV that we have completed. Array is equal to data frame dot values. Now I will segregate the data into the dependent variable and independent variable. So x is equal to array bracket colon 0 0 to a. Y is equal to array square bracket colon comma a. Estimators. Now we are creating the pipeline. Two things are there. One is a pre-processing, another is the algorithm. We will put both this thing into the pipeline to avoid the leakage of the data. So estimators is equal to the square bracket estimators dot append. We want to we want to standardize the data. So standardize using the standard scalar. Estimators.append LDA is a linear discriminant analysis. Model is equal to pipeline into bracket estimators. So this loop will start running. Basically, it's a pipeline. So k-fold is equal to k-fold. Number of splits, 10 splits are to be created. Random state are specified 7. It means that seed is 7. By specifying the seed, we are in the position to produce the same results every time. Shuffle is equal to true. Results cross validation score into bracket model will come from here x y cv k fold print results dot mean, and we got the answer 0.7669. The accuracy is quite good. This is the way we have avoided the data leakage problem using pipeline. The next thing which we have to understand is feature extraction and modeling the pipeline. Feature extraction is another procedure that is susceptible to the data leakage. Pipeline provides a handy tool called the feature union, which allows the results of multiple feature selection and extraction procedures to be combined into a larger data set on which the model can be trained. Important. The important thing is the feature extraction and the feature union occurs within each fold of the cross-validation procedure. In the example which we are going to discuss now, four things will be running simultaneously. One, feature extraction with the principal component analysis, 3 features. Feature extraction with the statistical selection, 6 features. Third, we will be using the feature union. Fourth, learn a logistic regression model from this. How we can do this? Let's see in Python. From pandas import read underscore CSV. From sklearn.model underscore selection import the gray fold. From sklearn.model underscore selection import the cross validation scores. Now here with pipeline, it is necessary that you also import the feature union. From sklearn.linear underscore model import logistic regression. From sklearn.decomposition import principal component analysis PCA. From sklearn.feature underscore selection import the select k-best. Now I'll be using the same database. Names are the variables. Data frame is read underscore CSV. File name is from where the data will be fetched. Names is equal to names of the variable. Now I'll segregate the data into the independent variables and the dependent variable. So x is equal to array square bracket colon 0 to 8. Y is equal to array colon 8. So I'm making y as a dependent variable. Now comes the feature. We are creating a loop. So square bracket features dot append PCA. PCA number of components which are to be extracted are 3. Features dot append select underscore best based on the basis of select k base 6 features. Now I will combine this two. So whatever variables which have been extracted in principal component analysis and whatever variables which have been extracted from k based, we are combining them. So feature underscore union features. Now comes the pipeline. Create the pipeline. Estimators is equal to square bracket estimators dot append feature union comma feature union. Estimators dot append, we will be using logistic regression. So features dot append logistic regression model is equal to pipeline estimators. K-fold is equal to K-fold, number of splits 10, random state 7 is specified, shuffle is true, results is equal to cross-validation score, model, X, Y, CV is equal to cross-validation is to be done according to the K-fold, print results dot mean. And we got the answer with the help of feature union and automated pipeline is 0.7708, which is considered to be quite good. All these codes are written in the book Machine Learning Mastery with Python, written by Jason Brownlee. For more videos on machine learning using Python, kindly subscribe to my channel. You can see my playlist in which I have already uploaded many videos of machine learning using Python. Please don't forget to press the like button. You can also follow me on LinkedIn and Twitter. Thank you.